Hey guys, this is Mr. Mice one more time here. Well, not one more time. I'm going to be here a lot, okay? But we got here higher order derivatives. And higher order derivatives, look, we have, since a derivative of a function is a function itself, it goes to say that the derivative of the derivative is also a function. We can actually take the derivative of the derivative. We can take the derivative of that derivative. Take the derivative of the derivative of the derivative. We can keep taking the derivatives. Now, any derivative that's higher than the first derivative, which is what we call it. So if we had y, and we take the first derivative, all right? Oh, well, I don't really want squiggly marked. But if we do the first derivative of this, we're going to have y prime. The next derivative is called the second derivative. What do you think that is? That's called y double prime with two little primes on it. And then what do you think the next one is? Yeah, that's right. It's the third derivative. And that is y triple prime. They're really, really inventive with this kind of stuff, guys. The fourth derivative is y. No, we don't actually put four little dashes next to it. Anything above three derivatives, we're actually going to just put the number there in a parentheses. So it's going to look like this, kind of like that, y fourth prime. So how does this look in function notation? This would be f prime of x, f double prime of x, f triple prime of x, f fourth prime of x. Okay, we can also go all the way to the nth derivative, f n of x, okay, if we wanted to. Just keep going, do all derivatives. It looks a little bit different when you're using the dy dx. Dy dx looks like this. So we know we have dy dx. This is d squared y dx squared. Okay, so it looks a little different because we put the squared in between the d and the y. This will be d cubed y dx cubed. All right, and same thing as you go down. So I just want to make sure that you understand that notation, just because you will see this notation come up when we look at multiple derivatives. Okay, so I want to do one example for you. I'll go and erase this real quick of a higher order derivative, and the example is going to be, let's have a function f of x equals 1 over 2 cube root of x squared. And we're going to go ahead and find f prime of 1 and f double prime of 8. Okay? So we're going to go and do the first derivative. Now, when we do this derivative, we want to make sure we change this first, right? So we're going to have 1/2 x to the negative 2/3. So make sure you change that into its root, or into its rational power, not its root. Okay? So we're going to take the first derivative. So the derivative using the power rule, we're going to multiply the negative 2/3 here. So I'm going to have 1/2 times negative 2/3 times, and I know I can simplify that, but I'm not going to do that right now. And I'm going to use the power rule, so I'm going to subtract 1, so that's really minus 3/3. So I'm going to have x to the negative 5/3, right? So if I want to find f prime of 1, which is what I'm looking for here, I'm going to go and plug 1 in here, and 1 to anything is just 1, so I'm going to end up with these cancel out. I'm going to end up with negative 1/3. Okay, so do you see I didn't really have to simplify that quite, because I only had 1 there. I could do it. I could do it here. Okay. All right. F prime of f double prime of x equals 1/2 times negative 2/3. Times, now I'm going to use a power rule here. So instead of doing the derivative here, I'm going to do the derivative of the derivative. Okay? So negative 5/3 x to the, now I'm going to do 3/3 again, so negative 8/3. All right? And so lastly, I wanted to find f double prime of 8. So 1/2 times negative 2/3 times negative 5/3 times 8. Was it negative 8 or 8? Oh my. This is 8 here, but really in my booklet for my students, it's negative 8. Okay, so I'm going to go put negative right there. Negative. And that's raised to the negative 8/3. All right, so I plug it in here, okay? And there we go. There's our answer. Like I said before, if it's a value for the BC exam, you don't have to simplify. Don't make your life atrocious by simplifying this guy. If you really wanted to figure it out, it's going to end up being 5/2304. But this is perfectly acceptable. Throw in the number, you're done. Boom, high order derivatives. Later.